the place that it was filled up from was the other side of the Earth. It was from the Pacific side that was providing the mantle, pushing down on the mantle to provide the uplifting of the mid-oceanic ridge. There's one place that's the center. If you look at the center of the ocean trenches of the Earth, the trenches are in the Pacific. The exact center of the trench area is exactly on the opposite side of where the Atlantic ridge would have started to rise. When the ridge first started coming up, material has to come from inside the Earth someplace to allow that ridge to go up. And without getting too technical here, it had to come from someplace, and material started to move in the Earth. By the way, when we're talking 4,000-mile radius of the Earth, from the center of the Earth out to us is 4,000 miles. We're talking almost the skin of an apple is the crustal area. But something has to move into that place. You can't have the void space. And because of the way the Earth was, and possibly the crust was a little bit thicker in the Pacific, it provided the extra push to push down the mantle to create it to come up over in the Atlantic to then cause these continents to move towards the Pacific. Does that help? Inner Earth material would have been moving towards the rising Atlantic. There are trenches because the crustal piece in the Pacific would have been bowing down as the Atlantic was rising, and there are thousands and thousands of volcanoes on the floor in the Pacific, and Dr. Brown theorizes this is how the very hot inner outer core, they call it the outer core, the very center of the Earth they know is solid, surrounded by the inner solid Earth is what's called the liquid outer core, followed by the mantle, followed by the crust. And Dr. Brown theorizes that the heat of this material moving to the rising ridges caused the viscosity, it added so much heat that actually other settling took place because of the different density materials and created a massive melting of the inner Earth, as well as creating even the magma that we see coming out on the Earth today. Also, and many people are, Walt, you must be wrong. Look at how far away Asia is from the crack in the Pacific, and so where's that crust? Well, in that area, the crust went down, and it's the ocean floor. And by the way, science has done some ocean floor investigation over in the western part of the Pacific Ocean. They dig down. They expect to find what they find in all the other oceans of the world, basaltic type material. There's crustal material, which is granite, and then there's mantle, ocean floor material, which is basaltic. What they find when they dig down in the western Pacific is they find crushed granite. The lava that comes out has granite in it. And so they're amazed by that. So when it lifted in the Atlantic, and by the way, see it's labeled flank rifts, axial rifts, and then there were fracture zones, because if you take rock and all of a sudden it bows up and goes into tension, it's going to create ridges. It's going to break and pop those cracks on the top. Those features are for the entire 46,000-mile length of the ridge. It proves that it came up in tension. And then it would have been a zipper. The first place it came up, it would have zipped from both sides, and it would have also been, as it was rolling up this way, it would have created fracture zones perpendicular to the axis. And that's what you see on the entire length of the mid-oceanic ridge. And this is all happening underwater at first, and the continents start taking a ride. Dr. Brown theorizes that they got up to the speed of 45 miles an hour. And again, Dr. Brown, he's an MIT mechanical engineer, doctorate, just using some basic assumptions. If you put mass in motion, what's going to happen? Well, when we watch train wrecks on TV and you sit there and go, wow, those heavy trains piling into a wall. Wow, that's a lot of energy, a lot of damage. Imagine the trillions of tons involved with a 10-plus mile thick continent heading west, going 45 miles an hour. When it runs out of its lubrication, or it runs into something, there's going to be some major changes that occur to those crusts. So the ridge grew. North and South America started moving towards the west. Europe and Africa to the east, both were lubricated with the remaining water, and off they went. As these forces of momentum are building up, the continents are coming crashing running out of lubrication. South America, if you look here, the Andes mountain range, which goes right along with the leading edge of the movement, the Andes mountain range, probably ran out of lubrication, ran out of water, is crushing down along on the mantle, and boom, starts lifting up and folding on itself. America ran into the Pacific Ridge, creating the Olympic Cascade Mountain Range from north to south, the Rocky Mountains, or a few cars back in the big train wreck, the Rocky Mountains bow up. A few more train cars back, the Appalachian Mountains bow up. And everything's coming to crash, and everything is moving towards the Pacific. Now, look at that. This is a mountain range in Canada. I think every Christian student should take this picture to their geology class, their evolutionary geology class, because this one picture destroys evolutionary layer theory to smithereens. Because layers do not lay down like that in folded layers. In other words, this picture really looks obvious that at one time those layers were horizontal, and while they were still soft, because this is solid rock now, while they were still soft, somebody took them and crunched them together and folded them. And this is not made up, that's real. Well, what in the world could fold soft before solidifying sedimentary, what is now sedimentary rock? There is no answer except the hydroplate theory. Everything has just been freshly laid down. It's underwater. The carbon associated with the carbon dioxide coming out of the fountains of the Great Deep had not been the cementing agent of this sedimentary rock yet. It was still not solidified, just like it takes a while for concrete to dry through the same cementing process. And so these layers have been laid down, they're soft. They're riding on top of the average thickness of sediments on the earth at the time was, now today is a mile thick, sitting on top of North American continent. North America goes for a ride to the west, comes to a crashing halt. The momentum, with all those layers laid down horizontally, the momentum says, I'm still going. Boom, 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 folds it up. Does everybody follow that? To demonstrate this, this is our sedimentary hydroplate. This is North America. And this guy down here is the mantle that it's going running on. And now I can lift this up pretty high, and it doesn't want to, that high. It doesn't want to take a ride because of the friction that's there. Now, evolutionary scientists say that all the mountain ranges were by the slow subduction process, the mantle going down, inches a year, pushing. Well, see, if I were to try, that's like saying I can push this sedimentary rock with a straw. Can I push this with a straw? No, the straw would crush. Within 10 miles into land, anything that's pushing on granite crust, 10 miles in, you cannot transfer that force because you'd be crushing it. There's too much friction of the crust sitting down on top of the mantle. Does everybody kind of follow that? You can't move something with